Hi, I'm Dom, and I'm a Senior Engineering Manager at NIB. Today, we're going to be talking about scalable pipelines and machine learning and conversational AI. A little bit about myself. I started out as a graphic designer many moons ago, and about 2 years in, I decided that it wasn't really for me, and I switched to being a full stack engineer. I've been doing engineering for around 12 years now, but back in 2017, I started out in conversational AI. And that's also when I first got into DevOps and working in a CI/CD sort of mindset. I joined NIB in 2019, and that is when I started using Buildkite. So, what are we going to cover today? We're going to talk about NIB's conversational products and tooling. We're also going to talk then about the multiple bots that we now have and how we use dynamic pipelines to scale. We'll then deep dive into our model training process using Amazon SageMaker and Buildkite. And then finally, how we expose those model training results via Buildkite annotations. So let's meet Nibby. Nibby is our conversational AI assistant. When I joined NIB in 2019, Nibby was on a handful of pages across the website, and that's about it. Didn't do a lot. It was basically an FAQ bot. We very quickly had to scale the bot to go across not just a couple of pages on the website, but the majority of our website, along with our member portal, our mobile app, and then in 2021, our voice bot via the phone system. That required that we had a number of different models, sales models, service models, and partner models for our people who sell our insurance through a third party. So we needed to have a way where we could deploy and build a model without having to replicate from scratch every piece of infrastructure and code over and over again and have duplication issues and that sort of stuff. And so that's how we've ended up using Buildkite as a critical component in how we've achieved that sort of scaling model. So for our conversational backbone, we use Rasa. And Rasa is an open source conversational AI platform. It gives us full control over our machine learning models that allow us to map our model performance between every individual build. And then on top of that, the ability to then version our models with the help of Buildkite and let us roll back to any point in time with confidence. I suppose as a side note, we do a fair amount of stuff in our pipeline, and we're not going to be able to cover everything today. Some of those things are our regression testing with Postman, our data streaming via Amazon Kinesis, and setting up Snowflake via Buildkite, which is our data lake for where we ship all our data. So let's go back to 2019. This is the initial pipeline that I created. It's pretty simple. There's not a lot going on. It all fits in one screen, and it's a single model basically for an FAQ bot. If we have a bit of a look at it, we can see that it is all the nuts and bolts is done in one step. The training, the testing, the building, and the artifacting ready for deployment into production. And it took a total of 18 minutes. You can see there's some pretty glaringly big issues here. It's a pretty small model, and there isn't, the fact we can do this all in 18 minutes is, I think, reflective of that. There's no tests on the data. It doesn't provide any sort of feedback to anyone as to how well the model performs. And this pipeline doesn't help us scale, doesn't facilitate our ability to scale. I guess I should put as a side note, we actually initially were doing our model training inside a Buildkite agent, and our Buildkite agents aren't spec'd particularly well. And if you're familiar with conversational AI or model training, you generally would like to have a GPU, and none of these machines have GPUs. So we were very ambitious to think we could, at any point in time for a long period of time, train inside a Buildkite agent of the spec that we have at NIB. So this is our current pipeline. And as you can see here, there's a little bit more going on. We've got 3 sets of training groups that operate. We then have 3 sets of development environments that deploy. And then finally, we have 3 sets of production pipelines that deploy. Obviously, there's a few other little bits and pieces that sit in between that. But there's a little bit more going on than that previous pipeline. And if we have a bit of a scroll through, you can see we've got Buildkite annotations set for our models. We've got results of our build coverage. We've got the ability to download the models directly from Buildkite. So yeah, we can roughly say it's a lot more comprehensive. And the big benefit of this, while it looks extremely complicated in this state, is the actual code behind it is actually quite simple. And a lot of this is self-replicating. So we're not actually having to cut new code every time we want to deploy a new model. And we achieve this by having a multi-bot architecture. And so what that means is that we have one single GitHub repo for all of our models across the group. And inside that repo, we have a common folder, which consists of NLU data and action data and sort of business logic that is persistent across the group. Things like how we disclose legal terms, how we transfer to agents, that sort of stuff. And then we pair that up with one of our subfolders. So for example, if we're building a sales bot, we'll take everything from the common folder and then we'll append it with the data from the nibby sales folder, and that will give us our conversational AI model for sales. And so we do this for each one of our models that we currently have displayed here. And that's how we get to a point where we can dynamically have new content and we'll roll out content off a single source. So we don't have to replicate things like webhooks and integrations, all that sort of stuff. It all just sits inside one repo. So how we scaled to multiple bots using dynamic pipelines. And this is the nuts and bolts of how we really did it. So we start off with a single pipeline YAML. We then, for each bot, have a bot pipeline bash script, which generates a pipeline train script and a pipeline deploy script. And then for production, we have a pipeline for just deploying. So we only train once in our development environment, and if we're happy with that, then that will ship into production. And so the reason why we have this is that we don't train twice, is that the way that our model training works is that sometimes we will find that there are slight variations in the training between when we've tested it in our development environment and if we retrain it again once we're in production, it can sometimes be a slight variance. So we take the model, package it up, and basically then ship it straight into production. So let's look at exactly what each of these files has. If we look at the pipeline YAML file, you can see I've cut a fair bit out of it, but the crux of what this does is that we have a bots environment variable. Inside that bots environment variable string is three values: nibby service, nibby partner, and nibby sales. And so when we want to add a new bot, we simply add to the end of that string nibby Buildkite. And so that would be our fourth model that would get created. And if we look down at the step here, you'll see that we have the call the bot pipeline bash script that will then echo out our new pipeline and pipe that straight into the pipeline upload CLI command that Buildkite supplies. You'll notice here as well, under the environment variable, we also have the pipeline type specified to train. So this will then call the train YAML file. So inside the bash script, we yank the environment variables from our core YAML pipeline YAML file, so we're not having to replicate those environment variables over and over again. We echo those out. We echo out steps. We then pull in the relevant pipeline type that has been specified from our directory, and then for each bot, we'll go through, we'll find and replace particular strings in that file to match what the bot that we're looking to train on, and then echo that out. So if we look at the pipeline train YAML file, you can see here we had in the previous slide, we had the bot name that was getting replaced. And as you can see here, the bot name here would be, for example, train nibby sales. And then we have a group key, which is group train nibby sales. Now, inside the train YAML file, we have three key steps. We have a build and train step, a test step, and a package up for deployment step. And as you can see here, again, at each step, we have the bot, which is an environment variable that we then replace as part of that previous bash script to reflect the current bot we're looking to build. So each time we go to do a new build or create a new bot, we never have to touch this file. We just know off the bat, this thing is just going to work. And so this is the resulting output of the pipeline train YAML file after that we have run the bash script on it. You can see here it has all the models output, and there's a lot of steps, but we don't have to basically hand code this over and over again. If we take a quick look at our deployment file, again, similar to the previous train file, we replace the bot name, and we also replace the deploy stage. So for obviously where we're deploying into our development environment, we deploy to dev, and we're deploying to production, we deploy to our production environment. And so behind the scenes, we have different AWS environments we deploy into and that sort of stuff. And so this is how we differentiate which environment we're going to deploy into. And there's 4 steps in this. So there's deploying a DynamoDB, and that's our state machine for Rasa to control the conversation state. We then also deploy an NLP server and an action server. So that's what's required to support the Rasa infrastructure. And then after we've deployed those stacks, we then do a smoke test to make sure everything's working just fine. So you might go, that's great, you've added 1 billion steps, how do you do this? And so the key piece here is that we actually still keep our build time down with explicit step dependencies. So basically every bot runs in its own swim lane. And for months, I was just using generic wait steps. And that was obviously, as you can imagine, blowing our build times out to hours upon hours. And so if you take a look at the new one, we have a build and test, and they all run concurrently, and basically we wait till everything's ready to go. And then we do all the deploys in one hit, and then all the regression hits in one go. And so it basically means that some models are quicker than others. So our sales model, for example, is quite small, and it doesn't take a lot of time to train. And so with that, it means we can burn through that process quicker and then get to the end so we can complete all these steps and then go to the next stage quicker and quicker. So that's how we can control our build times. And so, for example, our total agent time for one of our builds more recently is about 7.5 hours, but the actual build time is about 1 hour 30. So a human time, in terms of waiting from start to finish, is 1 hour 30, but the agent time is nearly 7 to 8 hours. So we're going to talk about how we actually now build and deploy our models. So we start with a code commit to GitHub, pretty standard, nothing fancy there, which then triggers a webhook in Buildkite. Now, once we're in Buildkite, we start splitting apart our data, and as I mentioned earlier with our multibot structure, and we can split apart our data and combine it to fit the particular model that we need. And so once we've split and combined our data, we push that data into S3, and we need it to be in S3 so SageMaker can pick it up and do a train on it later on. Once we're in Buildkite, we go back to Buildkite and we build a training image that we're going to then reference in SageMaker, and we push that to Amazon ECR. Once we've pushed to Amazon ECR, we then call SageMaker and go, right, we've got an image in ECR, we've got data in S3, can you do a train for us? And so it goes away and does a train, and we sit there and wait for SageMaker to complete that training process. And once that training process has come back, we check to see if it's any good, and we pass it on to Amazon FireGate to deploy if we're happy with it. So if we take an even deeper dive into the model training in SageMaker, this is how we do it with Buildkite. We start with obviously with the training step in Buildkite. We then do a quick check, which is to see if we have any changes to our training data. And if there aren't any changes to our training data, we go to S3 and download our previous model, and we end the training step. So we cut, again, the build time of the training step, this step down to a matter of about 1.5 minutes, 2 minutes if we don't have any changes to our training data. And we check the changes to our training data via command that Rasa supplies us, and also via command that we have in Git to basically do a diff check to see if there's any files in particular directories that we go, oh, we actually need to do a train on this one. You can also override this at any point in time as well. So we have a command that we can do, which is a force train. So if you commit something to GitHub and you have the force train in your message, it goes, great, doesn't matter what we find, we're going to do a force train. So let's assume there are changes to the training data. Do the training data checks pass? And so we have a number of checks that we run to ensure that we meet our data integrity requirements. And if those checks don't pass, we fail the build. Now, if the checks do pass, we do what is called an 80-20 split of our training data. So we take 80% of the training data. So say we have 5,000 training examples. We'll take 80% of those and we'll go, great, we're going to go and train the model with that 80%. And we hold 20% of that training data back to then use later in testing to ensure that the model actually is reflective of what we're hoping to achieve. And once we've done that split, we push that training and test data to Amazon S3. Once we've done that, we build a SageMaker Docker training image, and we push that training image to Amazon ECR. Once we've done that, we create a training job in Amazon SageMaker. And we basically, once we do that, we create that training job, goes to Amazon SageMaker, And then we'll create a second Docker command and we'll listen, which is basically a polling agent to basically go, hey, how's that training job going? How's that training job going? And once the training job has been marked as complete, we'll go see it's been completed, but was it successful? And if it wasn't successful, we'll fail the build. If it was successful, we'll download the model from S3 and we'll end the training step. So you can see here, we have a way of ensuring that we don't over commit to our build times and cause us additional costs if we don't absolutely need to do a train. And I think that's critically important as well when you're building these sort of pipelines, that you don't just instinctively train every single time. Only train when you need to train. So this is a little bit more of the detail again around how we actually do those Docker commands with Amazon SageMaker. And I've put a link in here to the tutorial that we used to kick us off the ground on this one. So we've added a little bit of custom logic that we need from an NIB perspective and a security perspective. So this is not necessarily 100% exactly what's in this tutorial, but as you can see here, basically there's commands in Amazon SageMaker to basically create a training job, and you pass in your S3 path where you want to output your S3 model. So where you want to output your model, so a path in S3, and then a number of different branches and what region you want to train in, what model instance you want to train on, and that sort of stuff. And so we behind the scenes have dynamic instance types and that sort of stuff that we train depending on if we need to push a build that quickly. Cool. And so I think the most critical piece now is once we've done all this training is how did it go? And so Rasa outputs a bunch of JSON files, which is great, but there's about 30 of them, and no one really wants to go through the artifacts tab in Buildkite and sit there and download every single one and open them up and look at them. So what we do is we transform them with a bunch of Python scripts to then output them in something that's a bit more human readable and digestible. So this is what it looks like at a very rough glance. And if we go to the next slide, you can see here, we actually have them interactive as well. So you can go in and deep dive and go, we've got 113 training intent issues. Let's have a look at those and see what the go is. And so the command I've got here at the top, very basic, write results.python, and we just append it to the annotation that we already have. And so we use Buildkite annotations extensively to help us in the build see exactly what is going on. And so this is not only helpful for our developers, but we also have a number of product designers and conversational designers who also will create builds when they're making changes to the NLU or their designs, and they can actually see the results without having to get all bogged down in the F1 scores and all that sort of stuff, or looking at all the files. So in summary, we've done a fair bit. We've done 6,100 total builds. Of those, 690 have been production builds, which is roughly around one model deployed per day since we've been live. And we still have managed to maintain our build time of 1 hour and 42 minutes, which I think is pretty good in all things considered, in the sense that when we went from 1 to 3, our build time increased by about 2 minutes. And that 2 minutes was because we were doing the data split at the start of the job. And there was no way to sort of pipeline that out or to split that apart any further than what we could. So I think that's something that we're pretty happy with in terms of to get something straight into production with all the model training that's required across all three of them. We hold true at 1 hour and 42 minutes. That's all from me. Thanks for watching. If you have any questions, please feel free to reach out. I was going to put Twitter on here, but I wasn't sure if this would still be around, if Twitter would still be around. So let's just go on these two. Have a great day.